Imagine you're a high school student staring down at an impossibly difficult geometry problem. One that the world's best math prodigies struggle to solve under immense pressure. Imagine an artificial intelligence that can crunch through these problems with ease, solving them almost as well as the brightest humans on the planet. Well, you won't have to imagine much longer. What's up, knowledge seekers and math fans? My name is Alex, and welcome to another video. In today's video, we're going to learn about an exciting new AI system called AlphaGeometry that is tackling complex geometry problems on par with math Olympians. Background. For those who don't know, the International Mathematical Olympiad is like the Olympics for math geniuses, where teams from over 100 countries send their most gifted high school math students to test their skills. We're talking next-level math that would make the average person's head spin. The competition problems are no joke. We're talking geometry theorems so tricky they leave even the sharpest minds scratching their heads. So how well do you think an AI would do on these super hard Olympiad geometry problems? Well, prepare to have your mind blown, because researchers just unveiled an AI called AlphaGeometry that is solving these problems at an incredible level. In fact, AlphaGeometry was able to solve a benchmark set of 30 Olympiad geometry problems, almost as well as human gold medalists. Out of 30 problems, it solved 25 under competition time limits. That's just unbelievable. The previous best AI system could only solve 10 out of 30. So in today's video, we're going to break down how this cutting-edge AI works and why it's such a huge deal for artificial intelligence. Get ready for some serious math and computer science because this stuff is mind-boggling. How AlphaGeometry works. Now, you might be wondering, how can an AI possibly solve these super complex geometry problems? Well, AlphaGeometry uses a really fascinating approach that combines deep learning and symbolic logic. Let's break it down step by step. First, AlphaGeometry has something called a neural language model. This is a type of deep learning algorithm that tries to predict relationships in data. Researchers have found that language models are really good at identifying patterns and connections, similar to how humans intuitively grasp concepts. However, language models alone can't actually prove anything. This is where the symbolic logic engine comes in. This component follows the rules of deduction to logically reason through problems step by step. So AlphaGeometry combines both. The language model provides intuition, and the logic engine provides rigor. It's inspired by the idea of fast, intuitive thinking versus slow, rational thinking. Here's how it works in practice. Let's say we feed a geometry problem into AlphaGeometry. The language model looks at the diagram and quickly tries to predict what new geometric constructs need to be added, like points, lines, or circles, to help solve the problem. This constrains the infinite possibilities into just a few of the most promising constructs. Then, the logic engine takes over and uses deduction to determine the geometric relationships created by adding these constructs. It keeps deducing new logical facts from the diagram until it hopefully arrives at the solution. If it gets stuck, AlphaGeometry loops back to the language model to predict another potentially useful construct to add. This cycle continues until the problem is solved. This cycle continues until the problem is solved. It's an incredibly clever combo of perception and reasoning that emulates how humans tackle geometry problems. We use intuition to get unstuck, but logic and proof to finalize the solutions. AlphaGeometry works the same way. Training with 100 million examples. But how exactly does AlphaGeometry's language model gain this intuitive sense for geometry in the first place? Well, the researchers came up with a super cool way to train it called synthetic data generation. Basically, they first auto-generated a massive data set of 1 billion random geometry diagrams. Then, they used symbolic logic to exhaustively derive all the geometric facts and relationships from each diagram. Next, they looked at which new constructs needed to be added to prove the existing relationships in each diagram. This reverse engineering helped teach the language model which constructs are most useful to suggest. After filtering out repetitive examples, they were left with a training dataset of 100 million unique geometry problems with varying levels of difficulty. This huge dataset gave AlphaGeometry an intuitive grasp of geometry by exposing it to millions of examples of how new constructs can prove relationships. It's a seriously clever training method that gets around the lack of existing training data. By artificially generating geometry examples, they could teach AlphaGeometry from scratch, no human demonstrations required. Alright, now for the part you've been waiting for. Just how well did AlphaGeometry actually perform on Math Olympiad problems compared to humans? Well, the results were seriously impressive. On a benchmark set of 30 Olympiad problems, AlphaGeometry solved 25 within the time limits, while the previous best AI solved just 10. For comparison, the average human gold medalist would solve around 26 problems, meaning AlphaGeometry is approaching that elite level. According to Evan Chen, a former Olympiad gold medalist who evaluated AlphaGeometry's solutions, its proofs are highly rigorous and follow the classical geometry methods that students are taught. In fact, based on solving geometry problems alone, AlphaGeometry passed the bronze medal threshold at recent Olympiads. That's just astounding when you consider that these are problems crafted to challenge the most brilliant math minds in the world. This demonstrates a massive leap in AI's reasoning capabilities. Just a few years ago, an AI even getting a single Olympiad problem right would have been headline news. But beating the top, humans across dozens of problems cements AlphaGeometry as a major milestone for AI. It's easy to just think of this as another AI beating humans at a game-like challenge. But make no mistake, AlphaGeometry represents a giant step towards more advanced AI reasoning. Let's discuss why this matters so much. First, complex mathematical reasoning has always been seen as an insurmountable hurdle for AI. So AlphaGeometry finally cracking the code on geometry proves these challenges aren't impossible. Second, its neurosymbolic approach, combining perception and logic, mirrors how humans tackle problems. Developing reasoning that loosely emulates the mind is key for building more general AI. Third, the synthetic data generation method shows how AI can learn entirely from scratch without human demonstrations. This could enable AI systems to make discoveries beyond what humans already know. And finally, math and geometry form the bedrock of many fields like engineering, physics, and computer graphics. So advancing abilities in formal reasoning and geometry specifically could enable AI to unlock new horizons across the sciences. When you consider these implications, it becomes clear that AlphaGeometry is much bigger than just solving some math problems. This is about pioneering AI that can expand the frontiers of knowledge. Alright friends, that wraps up our deep dive on AlphaGeometry and what it means for AI. It still has limitations. It focuses narrowly on geometry, whereas mathematically gifted humans excel across fields like algebra, number theory, and more. So, while AlphaGeometry might ace geometry class, it has a long way to go before it can call itself a math prodigy. But the rapid pace of advancement in just the past few years makes you wonder, how long until an AI surpasses the most gifted human mathematicians? The prospect is both exciting and humbling. Alright friends, that's our video for today. Let me know what you thought of AlphaGeometry, and subscribe if you want to see more AI videos like this. Until next time, keep curious and keep learning.